Good evening, everybody. Welcome to Turfgrass Epistemology. My name is TravisShaddox. It is July 11th, 2024. I hope everybody had a good 4th of July. And we are back on Thursday nights. It's been a couple weeks since I've been on Thursday nights, so it's nice to get back. Good to see everybody in the chat. Gray, Connecticut, Eric, Brady. Eric says, with all the insane rain and heat and sun, my yard is better than I have seen in a long time, and all I did was apply half a pound of urea. Okay, back around Memorial Day. Yeah, doesn't take much. If the conditions are right, just a little bit of food goes a long way. USMC, send some rain my way, yeah. Transition zone guy, Aaron Burrs, Michael Conroy. Good evening, everybody. We're going to get started here pretty quick. I have quite a bit of information I need to get into today. I've made a change to the members-only videos that go on Monday. They're going to stay as members-only videos for some time. I don't know how long. If you want access to that, then you have to be a member. Otherwise, it'll be released to the public realm. I don't know when. A month? I don't even know when. I haven't even made my mind up yet. But for the members who are paying real money, I think it's important that some content is especially for them. And that's the intent behind that, is to make sure that they understand that I appreciate their contribution to the channel and to turfgrass research. So I'm going to make sure that the members only videos on Monday probably stay that way for a while. We had a members meeting, I guess it was this last Tuesday, and we had 4 or 5 members show up. Had a good conversation. That was the meeting was more along the lines of what I anticipate developing relationships in the community of comfortable discussion. You can ask any question, doesn't matter. And there's no silly questions, and just kind of help each other get better at what we do. So I appreciate those members that were there on Tuesday night. And if you weren't able to make it, be sure to look in the community only, or the community tab on the YouTube channel. If you're a pro member, then it'll be linked, and you'll be the only ones to be able to see it are the pro members. So if you can see it, then you're invited to those Zoom meetings. We have one about every 2 or 3 months. If you want to meet with me one-on-one and discuss your own needs, whether it's a business or your own personal lawn or whatever, you can meet with me on calendly.com/TravisShaddox. Any time that's on that website, you can sign up for automatically. You don't have to ask me. You go through the whole process, and everything's automated after that. So anytime you see on there, you can sign up for, and I'll be happy to help you in any way I can in terms of consulting on turfgrass information. This is a long-form podcast type of show. So it's an hour or so, and then I load the audio to podcast. So don't forget that within about 24, 48 hours, even if it's a members-only stream, I do load it to the podcast platform. So if you want to listen to it while you're driving or working or whatever, that's kind of the way the show is sort of designed, is just to hang out and listen to it. And you can do that on podcasts as well as YouTube. The music tonight is from one of my favorite Texas blues band. This song was in 1973, a couple years before I was born. So look forward to that tonight. And we're going to go over a label at the end of the show tonight. I was going to go over some videos, but it's too much. And so I just chose a label of a product that many videos have gone over. So we're going to go over that instead, because I don't have enough time to get into all the various videos on liming turfgrass and all the misinformation that exists out there on that. So I'm going to go over just a product label. Mitch Berg, good evening. Yeah. Okay. So we've been going over soil testing. We're going to continue to go over soil testing, but the presentation format that I've been going over the last month or so is now completed. I'm going to go back into the scientific literature and discuss some of the literature on soil testing. Tonight's paper is from 2 really good authors, and it's a good paper. I will say that the conclusions and the substance of the paper is very easy to understand. It's very practical, but the methodology and the statistics in it are rather complex. So I'm going to do my best to, I don't even understand most of the statistics in the paper, but I don't want people to get lost in the minutia of the paper, because the take-home message of the paper is very important. Okay. So let's get into it. The paper tonight is from 2 authors, Turner and Waddington, in 1983. The name of the paper is Soil Test Calibration for Establishment of Turfgrass Monostands. Now, you're going to hear me refer back to a number of other types of soil tests, particularly the ion exchange bead soil tests, maybe even saturated paste or base saturation, some of these other soil test methods or philosophies. You're going to hear me refer back to them And I'm highly critical of those technologies and those methods because this type of information does not exist to the same degree as does information on valid soil tests, such as the Bray extractant, the Olson extractant, the Malik 3, Malik 1 extractant, and so forth. So this one tonight is entirely a Bray 1 extractant paper, okay? Bray 1 is intended for acidic soils, and it's intended primarily for phosphorus. And so you'll hear me refer back to some of these other tests, and I just want to make sure we understand that it's not that I'm convinced they don't work, it's that I'm not convinced they do work. And there's differences in those two statements. To say that I'm convinced that they don't work is me making a positive assertion on a negative claim. You can't do that. I can't claim something doesn't happen. But I can say I'm not convinced they do work. I'm not convinced the saturated paste works. I'm not convinced the ion exchange bead works. I'm not convinced basic kind of saturation works. I'm not convinced any of that works because there's just not enough information in the literature, if in some cases none, to convince me that it works. So there's no reason to believe that it works. The reason I'm convinced that Bray and Malik and so forth are useful is because of information that I'm going to go over tonight, okay? Let me answer this question real quick before I get into the paper. It says, USMC Thaxton 86. Someone asked on a previous soil test video, what portion of the 6-inch... Oh, yes, I remember that. Thanks for reminding me. The question was, what portion of the 6-inch sample should you submit? Is it best practice to mix all the soil together for whatever area you intend to sample test? So let me answer that now before I get started. Is when we say you take a 4-inch soil sample or 6-inch soil sample or whatever it is, we're taking the entire, from the surface all the way down to the depth of the soil sample, 6 inches deep. We're taking that entire sample. If you're sampling your lawn and you want to take a composite soil sample, you want to take it, you're assuming, if you want to take many soil samples and mix them together, the assumption in that is that you're looking for the average of your lawn or the mean of your potassium levels in your lawn. Okay, so if you're looking to get an overall average of the area, then take several samples, 6 inches deep, submit surface to the bottom 6 inches, blend them together in a bucket, and then take that subsample from that mixture. So that's the way you would want to soil sample if your intent is to assume, or your intent is to get the overall average of that area. And so if you want the average of a poor area, then you want to sample that area separate from the acceptable areas. So thank you for reminding me that. I've been getting that question. I always forget to answer that question, so I'm glad we answered it before we even started tonight. Okay, in the paper, Soil Test Calibration of Establishment of Turfgrass Monostands by Turner and Waddington in 1983. Remember, these papers are published in scientific journals. It's been a little while since I've gone over one of these papers. It's been a month or two. I went over, I think it was mental health awareness, and then we did some PowerPoint presentations and so forth. So we're back into our normal routine. We're going over scientific papers. And this paper was published in the Soil Science Society of America Journal, which is one of the journals of the Tri-Societies, the Agronomy Society, Soil Science Society, and the Crop Science Society of America. This is our top tier association, and this is one of the journals in that association. I don't know if I have a paper in here or not. I think I do have one paper in that journal. I don't remember. Okay, here we go. So fertilization of seed beds. Hang on, let me get my stuff situated. Fertilization of seed beds for turfgrass establishment is a standard management practice. However, very few studies have been reported in the literature relating cool season turfgrass response to seedbed applications of P, K, and limestone. Now, if you've ever heard, I'm sure you have, if you're going to be seeding a new lawn and let's say it's fallow, that's the time to apply sulfur. That's the time to apply lime. Or if you're low in potassium, low in phosphorus, that's the time when you can really put a lot out and blend it in. And that is true. You can do a lot of things at that time period without any fear of killing the grass because there's no grass there yet. It's fallow. However, when it comes to, say you have a low pH, let's assume that let's say you say the pH is 5.5 and you say that that's low, or you're not comfortable at 5.5 and you want to lime it. And you say, well, I can't really apply pounds and pounds and pounds of lime once the turf grass is established. It's easier to apply it before I seed it. That way I can get all that, material in there and raise the pH. It's true, you can do that. But the question is, how do you know it's beneficial? How do you know that you need to do it? This is epistemology. And it might sound foreign, or it might sound, I don't know how it sounds, but you might disagree with that. Well, it's 5.5, Travis. Of course you should lime it.
if you're going to before you seed it, you should lime the soil if it's 5.5 to try to get it up at least into the 6s. And my question is, how do you know? If you're going to say, well, I've always done it, that's a bad reason. Or I've done it and not seen a response, that's a bad reason. Okay? Because this paper tonight is going to show very clearly in more than one turf grass what happens if you apply lime prior to seeding on these turf grasses. It doesn't mean it's going to happen in every case. It doesn't mean it's going to happen all across the world. But in this location, you're going to see exactly what happens when lime was applied prior to seeding. So we continue. Also, in several of these studies, soil nutrient levels were not mentioned, or terms such as low, medium, or high were used to describe the soil. And this is very common. You see phosphorus and potassium. You see VL for very low and high. That's how they interpret the existing levels. The limited number and scope of turfgrass establishment studies are reflected in a wide disparity that exists among soil test laboratory recommendations for turfgrass establishment. Now, this publication they cite here, number 13, which is, let me go down here. It is the Survey of Soil Testing Programs for Turfgrasses, was published in the Communications on Soil Science and Plant Analysis. It's actually, I haven't read that paper. I tried to get a hold of it, but it discusses the disparity or the changes or the differences that exist when you send the exact same soil sample to various different labs. Now, this was in the 80s, early 80s. An association exists today that helps minimize those variations, okay, where the soil test labs are a part of an association that intentionally goes out and sends the same sample to all these different labs, and then they give the labs back the results so that they know where they stand and they know where they need to tighten things up or whatever it might be. So but remember, this was in the 80s where that didn't quite exist to the same extent it does now. So thus, if meaningful interpretations of a soil test are to be made, field studies are needed to determine the interrelationships among soil nutrient levels, applied fertilizer, and turf grass establishment response on different soils under various uses and with different species and varieties. The objectives of the study were to relate phosphorus, potassium, and limestone seed bed applications to the establishment response of monostands of 3 cool season turfgrass species, and to determine the optimum rate of phosphorus, potassium, and limestone seedbed applications for the conditions present. So it's a very simple question they're asking. What are the critical levels for phosphorus, potassium, and limestone in the soil prior to seeding, and how much do we need to apply in order to maximize establishment, either the rate or density or whatever they're going to be looking. They're going to be looking at quality in establishment. So if you've ever wondered, where does the phosphorus? We should apply phosphorus before when you seed. You definitely should apply phosphorus during seeding or during establishment or during sprigging or whatever. If you've heard that, it's not always true. In many, many cases, it is true. There's no question. Okay, there are cases where during turfgrass establishment, the application of phosphorus can be beneficial. And tonight's paper is going to be one of those papers. Okay, but that's why I'm convinced that can happen, because there's evidence to support that. But if you've ever heard you should apply lime prior to establishment, it doesn't always happen. It's not always the case. And I'm gonna show this paper, then I'm gonna show a label tonight, and then I'm gonna show a USGA quote from a long, long time ago about this very same problem. It's been going on for over 100 years. This same issue with applying lime to turfgrass it's not new. It's over 100 years old, and I'm going to show you a quote from an older journal on this exact issue. Materials and methods. Now, I've said it before. I'm going to read this, and I'm going to do my best to explain the statistics, but I've taken, graduate level stats 1, stats 2, field plot techniques, a variety of different high-level statistics courses, and I've never once come across this specific model. But, so I'm unfamiliar with it. I've never used it. I've never seen anybody use it. I don't know how to analyze it. But from what I understand, it's a very appropriate model to determine these surface response characteristics that they're going to show in this paper. But just understand, I can't answer a whole lot of questions about it because I'm not an expert in this particular model. This experiment was conducted on a Hagerstown silt loam at University Park, Pennsylvania. Soil test results in September 1979 prior to fertilization treatments applications were a pH of 5.7. So we're in the fives. 600 kilos. So this is around 25 to 30 parts per million phosphorus, 60 kilograms per hectare for those metric people, somewhere a little bit below 30 parts per million phosphorus, and 0.18 and 0.7 and 4.3 centimoles of positive charge. That's a weird metric, but for potassium, magnesium, and calcium. So they measured potassium, magnesium, and calcium. We don't really use that metric anymore, but cation exchange capacity was 8.4. So for those base cation saturation magicians and grifters in the audience, this pH is well into the range that most base cation saturation salesmen would say that that's definitely a pH that, or a CEC, that it qualifies as a base cation saturation CEC. Soil pH was determined using a 1-to-1 soil paste. The available soil nutrients were determined using Bray number 1 extractant for phosphorus and neutral normal ammonium acetate extractant for potassium, magnesium, and calcium. So it's a very appropriate soil extractant for both these elements, phosphorus and then the other elements. The Malick 3 had not yet been published. This was published in 1983. Dr. Malick didn't publish his Malick 3 paper until 1984. Okay, so back then, this was in the middle of development of new soil test extractants. But even if Malick 3 had been around, this would still be a perfectly fine extractant to use. This is an acidic soil, and the Bray 1 extract for phosphorus is very appropriate to use on acidic soils. Current soil test interpretation showed phosphorus as low and potassium as a low to medium. Recommended rates of PK and limestone were used for the center point treatment. So I'm going to explain the center point treatment thing in a minute if I can. But in other words, they're establishing turfgrass on a soil that the existing soil test interpretation identified phosphorus as low and potassium as medium to low. Okay, so you wouldn't want to do a test like this on a soil that had very, very high phosphorus, because you would probably never see a phosphorus response. In order to see phosphorus responses or any nutrient responses, it has to be conducted in the right location where that nutrient is deficient or very low. And this particular location appears to be very appropriate for this type of study. It was low in phosphorus and medium to low in potassium. 3 studies were conducted within this experiment to provide treatment evaluations on 3 turfgrass species. September 1977, barren Kentucky bluegrass, an Atlanta chewing fescue, and a pin-fine perennial ryegrass were seeded. Due to severe weather injury, all ryegrass plots were reseeded at a rate of 2.5 kilograms per R on April 29, 1978, after the existing ryegrass plants were removed. So this happens a lot, where you put out a study and then something happened. In fact, if you look at my backyard right now, I have a study on my backyard, and we have my daughter's birthday. She had this big blow-up water slide thing, and it just completely killed a bunch of my tall fescue, just a straight line where the tarp was, and some of it's on my study. And the same thing happened there. Well, a similar thing happened with this particular research back then, where they went out, they seeded everything, and then one of the grasses dies. You can't control everything. And so they reseeded that grass, and they make a note of saying that in the paper. Okay, the center point. So the experimental design used for this study was a 5x5x5 central composite rotatable design with phosphorus, potassium, and limestone treatments. Now, that's a whole lot of word salad in my mind. I don't know what a lot of the details of central composite design are, but basically they pick a point in the middle, like say for phosphorus, I think they pick 6. And then they'll pick one on the low end and on the high end. And then there's the way that they design it is they have these star points around the center point, and from there they can develop what's called a surface response map, basically. And you're going to see a lot of those on this paper. I can't explain it much better than that, because, like I said, I've never used it. I've never been trained on it, and I'm just not that knowledgeable on it. So, but they do explain the center point treatment combinations were, when it says 4 kilograms of phosphorus per R is 8. That's 8 pounds of phosphorus per 1,000 square feet. Now, remember, this is prior to establishment. This is the soil's there. They're tilling this end of the soil, so it's quite high rates. Okay, you wouldn't apply this to established turf. These are very, very high rates, but it's prior to establishment, which is somewhat common. Those rates are somewhat common. 14 pounds of phosphorus per 1,000 square feet and 120 pounds of limestone per 1,000 square feet. There's a lot of material going into that soil. This pre-plant nutrient methodology is what they're using in this particular study. The phosphorus, potassium, and limestone were from triple superphosphate potassium chloride and granular limestone. They were incorporated into the soil into the top 11 centimeters. Okay. So top 4 or 5 inches. Okay. On September 29th, 1977, 3 pounds of nitrogen from IBDU and 1 pound of nitrogen from urea were applied and raked into the surface, the top half an inch of soil prior to seeding. Okay, so that's how they prepared the soil. They put all these nutrients into the soil, and they basically mixed it all up in the top couple of inches, all right? If you have a question, just put them in the chat, and I'll come back to I see your questions, Mason. I'll come back to those questions, and I'll do my best if I remember to answer your questions before the end of the show, or right after this, before I do the labels and the other stuff. Okay, in the spring of 1978, following establishment and prior to the reseeding of the ryegrass plots, 2 pounds of nitrogen from IBDU was applied to all plots, and 1 pound of nitrogen as urea was applied to the ryegrass plots before seeding. So the same amount of nitrogen was applied when they reseeded it. The area was irrigated as needed throughout the first year following seeding. Mowing height was 1.5 inches, and clippings were removed. Okay. By the way, I'm doing these conversions from metric to English on the fly, so I'm very likely to make a mistake. All right. If I make a mistake, just let me know. Especially I'm using this R unit, which it's 100 square meters, and it just flips. It just doesn't work in my brain to convert it into English units. So I might make a mistake, but I'll do my best to get it corrected. And if I don't, then make a note of it, or say something in the chat, and I'll call it out. Composite soil samples from all species plots within fertility treatment plots were taken on October 25th, 1978 for soil tests using methods listed previously. Fresh weight yield was measured periodically for 4 days of growth by weighing the clippings. Clippings were saved in 1978 for elemental tissue analysis. I don't need to go through all that. Nitrogen was determined using Keldol, which is a very typical, common way back then. In fact, it was typical all the way into the early 2000s. So basically, they took some samples, soil samples. They took tissue samples. They do show some tissue analysis and soil analysis. I'm not going to show a whole lot on the tissue analysis. There's just not a whole lot there, but if you want to, you can feel free to go back and read the details. They do have details on the tissue analysis. I don't think I'm going to go over a whole lot of that. In November 1977 and April 1978, the relative rates of turfgrass establishment were evaluated by estimating the turfgrass cover, the percent of soil surface covered by green vegetation. Periodic quality ratings were on 0 to 10, with 0 being dead and 10 is the highest quality, were made following these initial cover ratings. Recovery of the turfgrass species from mechanical injury was evaluated in fall 1978. So the mechanical injury, they just verticut it. So they verticut it, and they wanted to see how much recovery from injury would occur through that method of injury. They also used a sod strength. So they measured sod strength. This is one of the earliest papers I've seen that they did it this way, where they measured sod strength of bluegrass and fescue turf in 1978 using a technique similar to that described by Reich. And so the sod, what they do is they take the sod and they put it on basically a table. On each side of the table, they have clamps that clamp down over the entire width of the sod. And then on each side, they have it's like a torque wrench kind of thing, where they can measure the amount of strength required before the turfgrass actually breaks apart. And that's called sod strength, or that's how they measure it. And it looks like a medieval torture device is really what it looks like, where they're just literally ripping the turf apart and they're measuring the force required to do that. They did that as well. They also measured dandelion, mouser chickweed infestation as well. Okay, so that's the setup. They're in Pennsylvania. They're looking at 3 different turf grasses. They're looking at a Kentucky bluegrass, a chewing fescue, and a perennial ryegrass. They're mixing phosphorus, potassium, and lime into the topsoil prior to establishment. They mixed a little bit of IBDU and urea in the top inch or so, and they seeded it. Okay, and they're measuring quality and establishment and some weed infestations, a variety of different things in the late 1970s. Okay. Now, I'm going to skip through a lot of this, to be frank, because I don't understand it. Okay, I only understand bits and pieces of it, and I don't want to screw it up. So basically, what I'm looking on the page here is a whole lot of equations, and from my understanding, these equations are what were used to determine the relationship between these variables, and you're going to see some maps and some graphs that show it they depict it visually, the response or the results better than these equations do. Okay. I'm not going in the first part here. They're going to talk about tissue analysis, and I'm not going to really talk about that a whole lot. So yeah, tissue phosphorus with no fertilizer phosphorus applied would be critical. So they talk about tissue phosphorus and tissue potassium, but not really a whole lot happens. Okay, so we're going to go down to clipping yields. Now this is actually stuff that they're measuring, that responds to the turf grass in terms of something we would care about, clipping yields or establishment percentages or something like that. Okay. So for bluegrass clipping yields, phosphorus applications affected clipping yields on each sampling date through June 27, 1978. However, after this date, phosphorus no longer influenced top growth. So what they're saying is very simple for bluegrass. During the initial weeks and months of establishment, the application of phosphorus enhanced the clipping yields, but after the turf grass was established, there was no need to apply that much. There was no benefit to it. Clipping yields increased linearly with applied phosphorus for these dates, although the relative effect decreased with each successive sampling, indicating the greater importance of phosphorus in the earliest stages of seedling growth. Okay. Limestone applications decreased clipping yields slightly where no potassium was applied, and increased growth where potassium was applied, with the degree of increase greatest at the higher potassium rates. I'm going to show some figures on this in a second for those watching. These results may indicate that a minor nutrient imbalance or antagonism had occurred in September, where high rates of either limestone or potassium were combined with low rates of the other. Limestone applications also affected clipping yields on several other dates. Clipping yields for the May sampling date were decreased by limestone applications. I'm going to show you that figure in a minute, which may have been due to reduced availability of added or soil phosphorus due to reaction with the added limestone. On June 27th and July 11th and August 21st, clipping yields tended to be greatest at a limestone rate of about 61, so 120 pounds per thousand. So what they're saying is that for the clipping yields, this was for Kentucky bluegrass, for bluegrass, the application of limestone resulted in a reduction of growth. And then in June, July, and August, there was a little bit of an increase. Okay. Let me show you that in a graph format. It makes more sense whenever I show it in the graph down here. So let me see if I can get the graph on the page. I think you guys can see this. So here is the graph. This is the three-dimensional model that is a result of that central composite design. I was talking about the surface response graphs. This is what this is. On one of the y-axis, we have yield, and then we have lime on the x-axis, and we have P on the z-axis. And as what this is showing is, as lime is going from 0 to 120 to 240 pounds per thousand, the yield is going down. It goes from 30 grams per square meter to probably around 15. So this is clear evidence in this particular bluegrass trial that there was no need to apply lime. The greatest yield occurred with no lime. The least amount of yield occurred with the highest amount of lime. And when we applied phosphorus with the high lime, we did see an increase. So I'm going right here. When we applied phosphorus with the high lime, we went from 0 to 8 to 16 pounds per thousand. The yield went up at the highest lime rate, but the yield also went up at the lowest lime rate down here at 0. The yield went up as phosphorus went up. So in other words, phosphorus resulted in an increased yield, whereas the lime resulted in a reduction in yield. So therein lies the reason why I ask these questions. How do you know you need to apply lime? And I'm going to show you this again in multiple graphs. How do you know you need to apply it? Because I can show you paper after paper after paper that shows the application of lime actually either doesn't result in any beneficial effect or results in a negative effect. And yes, there's papers that show the opposite. There are papers that show a beneficial effect for sure. Okay, I can show you some of those. But there's just as many that show nothing or a negative effect as well. So how do you know? Okay, if you're out there selling lime applications as revenue, then that's so be it. But in terms of the agronomic value of that, you may be shooting yourself in the foot. I'm not saying you are, but you might be. It's very possible. that's either not providing any benefit, or it's actually resulting in a reduction in quality, a reduction in yield, a reduction in growth, and so forth. Okay, we're going to continue. I'm going to show you it again in many other graphs. Okay, here's the bluegrass that first one was in May of 1978. In June of 1978, you see again the same yield, lime on the X and phosphorus on the Z, where lime's going from 0 to 120 to 240, and you see it go up a little bit when at 120, but then go down when it gets to 240 pounds per thousand. It's a lot of lime. Okay, so there's a reduction. In other words, if you didn't apply anything, it was the same thing as applying 240. There was a little bit of bump in the middle. Okay, once again, phosphorus resulted in a little bit of an increase. Okay. The next one is the bluegrass, the same thing in September 1978, where there's essentially no benefit. There's a little bit of decline as lime increases. Goes from, well, I can't read those numbers, but probably 25 down to 24.3 grams per square meter. Not a whole lot going on with lime in the fall. A little bit going on with potassium, not a whole lot, but the yield goes up a tiny bit when you go from 0 potassium to about 30 pounds of potassium per thousand pre-plant incorporated. So a little bit there, but not a whole lot with potassium or with lime in September. Okay. Chewing red fescues. Phosphorus applications affected clipping yields only on the first sampling day of the chewing red fescues, with yield increasing linearly with applied phosphorus. Potassium influenced clipping yields during 3 sampling periods, with yield increasing slightly with applied potassium. So for chewing red fescues, there's a little bit of a benefit to phosphorus. There's a little bit of a benefit to potassium. Limestone applications affected yields slightly during 2 sample periods, with yields increasing linear with applied limestone. So with limestone, there's a little bit of an increase with limestone. So chewing red fescues didn't have a whole lot of influence, but where there was an influence, there was a little bit of an increase with phosphorus, potassium, and limestone with chewing fescue. Perennial ryegrass. The only date for which clipping yields were not affected by any fertility treatment was June 27, 1978. Before this date, growth was influenced only by phosphorus and limestone applications. So it sounds good, right? Oh, influenced by phosphorus and limestone. What are you saying, Travis? Let's continue. On June 2nd, yield increased to about 8 to 12 pounds per thousand of applied phosphorus, with the greatest increase in yield per unit phosphorus applied occurring at the lower phosphorus rates. This happens a lot, where it's like a sigmoidal curve, where at first you don't see a whole lot, and then you see a great deal of increase at the low rates, and then it stays linear, and then it kind of plateaus off at the top. That's very, very common in the literature. So the biggest bang for your buck is at the very lowest rates of a lot of elements. Okay, so that's very common. Also, clipping yields decreased linearly on this date as applied limestone increased. So once again, for perennial ryegrass, the clipping yields decreased with increasing lime. Nearly the same trend occurred on June 13th. Clipping yields tended to peak around 8 to 12 pounds of phosphorus. However, the greatest yield increase per unit phosphorus applied occurred between the 0 and 4 pounds of phosphorus. So at the low rates is where you saw the benefit. Yield, once again, decreased linearly with applied limestone. As stated previously, liming may have limited phosphorus availability. However, phosphorus concentrations in ryegrass clippings was not significantly affected by liming. Only with ryegrass did liming decrease both yield and nitrogen content in June, and these decreases may have been associated with volatilization losses from urea. They don't really know why it happened, but it's possible that lime resulted in increased volatilization from the applied urea. It's possible. It's also possible that the limestone bound some of the phosphorus into an insoluble form. That's also possible. They didn't really measure all that, but they're well within their rights to postulate why they believe it's possible they saw the results they did from applying lime and the negative response they saw. In July and August, clipping yields were affected only by potassium and limestone applications, whereas in September, phosphorus, potassium, limestone affected yields. On both July dates, yields tended to increase at rates above 14 pounds of potassium per thousand. So here's an example where potassium could be a benefit for perennial ryegrass if your soil is already low to medium in potassium during establishment. In August and September, yields increased slightly as potassium applied increased. Limestone applications did not affect growth on July 11th, but tended to increase yields on July 25th at the higher rates. Figure 2C. Let's just go to the figures. Okay, so these figures over here in ryegrass, you'll see this, it looks very similar, these three-dimensional surface response models. You'll see yield, limestone, and phosphorus. And again, this is what they're talking about when they say the limestone resulted in reduction in yield. It basically looks very similar to the previous plots where from 0 to 120 to 240 pounds per thousand, the yield goes down as limestone goes up. When phosphorus was applied, it also goes up, even at the high lime rate or at the low lime rate. The greatest increase was at the low lime rate right up here. So when no lime was applied, but high amounts of phosphorus was applied, it was the greatest yield in June of 1978. And then you'll see a very similar plot in terms of its curvature and the response surface. And that was on June 2nd. On June 13th, you'll see the same thing where the yield is much greater, but you see the magnitude is much greater, but the response is the same, where the greatest yield occurred at the highest phosphorus and the lowest lime application rate. Okay. For the July and then the September applications, the responses differed this is potassium and lime. Oh, they put lime on a different scale here. I see. So, okay. So on this one, we're looking at yield. Potassium is on this x-axis and the lime is on the z-axis. I guess that's the z-axis. I don't know what well on these three-dimensional models. But anyway, you see a little bit of an increase with potassium. It's not a whole lot compared to 0, but there's a little bit there. And then you see with the lime, again, there's not really a whole lot there, but a little bit with the application of lime. So you're going from applying no lime to applying a lot of lime, and you see a little bit of an increase. Again, it's probably not financially, you're not going to get your money back on that, but there is a little bit of an indication there that there was a benefit to applying lime and potassium, albeit very small. Now, in ryegrass in September, the benefit was greater, where it goes from 0 with phosphorus up to 16 pounds of phosphorus, and you see this increase is substantial here. Whereas with lime application, once again, there's no benefit. It's just a flat line. So once again, either phosphorus generally increased it, lime generally had no effect, or decreased the yield of ryegrass. Bluegrass, we're looking at, I thought we just did bluegrass, clipping yields. Why'd they go back to bluegrass? Oh, ground cover, turfgrass quality, and sod strength. Phosphorus applications generally had the most important influence on bluegrass establishment. Rate of establishment as evaluated by percent ground cover was increased by phosphorus applications. Ground cover 5 weeks after seeding in the fall was about 24% less cover on 0 phosphorus plots than on plots receiving 16 pounds of phosphorus, figure 3A. I'll show that in a minute. The following April, a similar response was still evident, with 0 phosphorus plots having approximately 23% less cover than plots receiving the 16 pounds. So clearly there was an influence by applying those high rates of phosphorus. On both of these dates, potassium applications decreased ground cover. 5 weeks after seeding, 0 potassium plots had 19% more cover than plots receiving the 30 pounds per thousand. The next April, 0% plots had 20% greater ground cover than plots receiving the highest K rate. So once again, I just showed some results that showed potassium had a slight benefit, not a whole lot, but a little bit of benefit in one of the grasses. Another grass that had no effect. And on this bluegrass establishment, it actually resulted in a reduction. If you applied potassium, applied potassium, and you incorporated it, it resulted in a 20% reduction right here, 20% greater at 0 potassium. Although not measured in this experiment, soluble salt levels from high rates of muriate of potash may have been sufficiently high to cause injury to some seedlings. And so they're applying potassium as KCl at very high rates. They don't know if that salt was why they saw a reduction in establishment. They don't know if that's what it was, but it could have been. And you're applying potassium, whether it's potassium chloride or potassium sulfate, you're applying it as a salt. Don't forget that. Turfgrass quality in May and June 1978 was the poorest on 0 phosphorus plots and was the best at 8 pounds phosphorus per thousand. Okay, although there was little additional benefit from rates higher than 8 pounds of phosphorus, figure 4A. After June, turfgrass quality was no longer affected by any of the fertility treatments. However, turfgrass on 0 phosphorus plots appeared to be somewhat less dense and wider bladed than plots receiving phosphorus applications. So here's these graphs, very similar to what we were just looking at. Now we're looking at percent cover on the y-axis. I think this might be the y-axis, and then the x-axis here with potassium and phosphorus. So now here we're looking at Let me see if I can zoom in, because this is phosphorus and potassium on establishment. And you're looking at from 0 potassium here, we're going up to 14 pounds into 30 pounds of potassium per 1,000. And we see this reduction in percent turfgrass cover. Okay. When you start with 0 phosphorus and go up to 16, you see an increase in turfgrass cover. This is about as clear as I can possibly make it when it comes to the value of phosphorus during establishment when soil test phosphorus is already low, and the potential, not always, but the potential deleterious effects of applying other elements, in this case like potassium and like lime. Okay. You can see a reduction in potassium. And I don't know where this idea came from where, oh, we can apply potassium because there's no harm in it. It can only help. Well, we've shown numerous papers that show there's disease increases by applying excess potassium. And here's a paper showing whether it's from the potassium or whether it's from the salt that comes along with the potassium, that the application pre-plant on bluegrass and on the other turf grasses as well will generally show a no effect or a reduction in cover for turf grasses pre-plant potassium. Okay. When you look in that was in October, that was in November. When you look in April 1978, you see a very similar graph. Establishment goes down with increased potassium, and establishment goes up with increased phosphorus. Pretty straightforward. Okay. Sod strength was affected by phosphorus and limestone applications, and an interaction between the two occurred. Combinations of both the highest limestone and phosphorus rates, or no limestone or phosphorus, resulted in the weakest sod. So that's just showing that the curve, in other words, the curve's not going up consistently. It's going like up and down. One element's affecting the other. One fixed effect is influencing the other. That's all it's saying. All right, chewing fescue. Rate of establishment was influenced only by phosphorus applications on chewing fescues, with 0 phosphorus plots having a ground cover of 48% at 5 weeks, whereas 60 and 64% for plots receiving the 16 and the 8 and the 16 pounds. So again, phosphorus is resulting in an increase in establishment. Okay. Turfgrass quality was influenced in May by phosphorus applications, but was not affected by any fertilizer treatment in June, July, and August. In May, the poorest turfgrass quality was from 0 phosphorus, and the best was from the 8 and the 16 pounds of phosphorus. So that's pretty straightforward. Okay, phosphorus is having an impact. Sod strength was influenced slightly by limestone and potassium application. So once again, if you read that sentence and you pull it out, and you go, oh, well, phosphorus, here's one, Travis. Again, limestone and potassium are influencing sod strength. Well, yeah, it's influencing. It's just influencing it in a negative way. And it says slightly by limestone and potassium applications, and was greatest with no limestone and 14 pounds a K. So this is in figure 5B. So what they're talking about is this right here, this little graph right here. Okay. So where we're going up in lime on this axis, we're going from 0 to 120 to 240, and you see the sod strength going down. And then you see the potassium have virtually no effect. There's a little bit of an increase when you go from 0 to 14 pounds, but not much. It goes back down at 30. So there's a little curve there. It's not really a whole lot when at the high lime rate. Now at the low lime rate, it's a sort of the same effect. There is a little bit of a bump there with a tiny bit of with the potassium, but then it goes right back down. So you can make a very good argument that unless you got it dialed in on the head, that you might apply potassium and see a little bit of a bump. You might apply more potassium and see it go down. Unless you know exactly what to apply, you're probably better off not doing anything when it comes to potassium, and at least in fescue establishment. Or sod strength in this case. Here's the graph here that I was talking about, where you're looking at like a interaction where sometimes the lime causes a reduction, sometimes the lime might have no effect, sometimes the potassium causes an increase, sometimes the potassium causes a decrease depending on the other one. So that's, if you want to see what an interaction looks like, that's what it looks like. Same thing up here on this graph. The graph looks all like skewed, where the lime going from 0 to 240 on the quality of fescue in October of 1978, you actually see an increase when the lime goes up, so there's a benefit. But you see a reduction when the phosphorus goes up at that high lime rate, but you'd see an increase with the phosphorus at the low lime rate. That's an interaction. Okay, so you you're going to be applying a lot of phosphorus and applying a lot of lime. You could probably get the exact same thing happen by not applying any. Well, you can. This little point right here and this little point right here shows that you can apply all this lime and no phosphorus, or you can apply no lime and a lot of phosphorus and get the exact same result. That's the best three-dimensional model I've seen of an interaction in the literature. Okay. We're getting close to the end here. Okay, so a perennial ryegrass establishment rate was related only to phosphorus applications in November 1977, 5 weeks after seeding, and again in May 1978, 4 weeks after seeding. Phosphorus rates higher than 8 pounds caused little further increase in ground cover. Phosphorus applications improved turfgrass quality in June and July, primarily due to density differences, but did not affect quality after July. So again, early on it was beneficial. Once it was established, the additional phosphorus was not warranted. Quality increased in June and July up to a rate of about 8 pounds of phosphorus with no additional benefit occurring at higher rates. So there you go. Okay, so we're going to get into the weeds and then the conclusions. Weed encroachment and recovery from mechanical injury were not related to fertility treatments. Average weed counts were 3 and 2, basically 3 plants per pot for dandelions and mouse ear chickweed. Possibly not enough time was allowed for significant weed population differences to develop. That's probably true. There is clearly an effect on weed populations, on some specific weed populations, and the type of fertilizer that you're applying. If you don't believe me, you can just go to Rotham Stand and you can see all the dandelions growing in certain types of certain plots that receive the same fertilizer for like 100 years. But in this case, they didn't see it. But this was only a very short study, so they postulated probably didn't last long enough to see a difference. The results indicate for all 3 turfgrass species, this is the conclusions, that an initial soil level of 100, so 25 to 30 parts per million phosphorus was not, remember, this is Bray 1. You can't convert that to Mehlich 3 very easily. So don't try to convert it and say, well, Travis said 25 to 30 Bray 1 is fine. So 25 to 30 Mehlich 3 must be fine. It's not the same conversion. It's not the same value. But 25 to 30 Bray 1 was not sufficient for rapid establishment on this Hagerstown silt loam. Seedbed applications in the range of 3 to 8 pounds of phosphorus proved to be most satisfactory in promoting rapid establishment. These applications subsequently resulted in soil phosphorus levels of approximately, I can't read that. It's like a 100, so 200 and, no, I see. So about 60 to about 80 parts per million. So around 60 to 80 parts per million of Bray 1 is what they're saying is necessary to hasten establishment to the point where you wouldn't need to apply anymore. However, when rapid establishment is not critical, the initial soil phosphorus level of 25 to 30 parts per million Bray 1 may be sufficient to obtain a satisfactory stand of Kentucky bluegrass, chewing fescue, and perennial ryegrass. And that's the reason I wanted to point that out. I'm glad they put that in there, is that it depends on what the expectations are. You don't need to go out and throw out all this phosphorus. But if your client or your coach or your golf pro is hell-bent on getting it grown in as fast as possible, then, and your phosphorus level is 25 to 30 Bray 1, and you're seeding these turf grasses, then there may be, and very likely would be, a measured increase in the establishment rate. But if you don't have that pressure to grow it in 7 weeks or whatever, then the phosphorus level 25 to 30 Bray 1 is probably fine. And that's where I fall in. I've seeded my yard I don't know how many times, and I have a big brown square in my backyard now. I'm going to have to reseed this fall. I don't care. I'll reseed it, and it'll grow in 10, 11 weeks or whatever it is. It'll be fine. I probably won't apply anything to it. But that's my expectations. If you have a client that has a different expectation, then that's where these phosphorus levels or these phosphorus applications might prove to be beneficial. So it depends on, what your expectations are, your client's expectations are. The last 2 or 3 points in the conclusions. Percent ground cover 5 weeks after 1977 fall seeding and also the following April increased up to approximately 8 pounds of phosphorus with little additional increases in ground cover occurring at the high phosphorus rates. The greatest increase per unit phosphorus applied occurred between 0 and 3 pounds. So if you want the most return on your dollar, the most return during establishment of these turf grasses on pre-plant incorporated phosphorus occurred between 0 and 3 pounds of phosphorus. That's where you get the most return on the phosphorus that you applied. You keep applying more and more, you get less and less return for it. Turfgrass quality, primarily due to density differences, continued to be affected by phosphorus applications through June, May, and July of 1978 on bluegrass, fescue, and perennial ryegrass, respectively. Quality generally improved up to approximately 8 pounds of phosphorus, with little additional benefit occurring at higher rates. However, after these respective dates, quality was not substantially improved by the phosphorus applications, although the zero phosphorus plots in the bluegrass study continued to be somewhat less dense through 1978. There was no difference among plots receiving phosphorus. So in other words, again, there was a benefit to applying phosphorus, but there really wasn't that much benefit to applying a lot of phosphorus. Clipping yields were increased by phosphorus primarily in the early stages of establishment. The clipping yields of bluegrass, chewing fescue, and perennial ryegrass were not substantially affected by phosphorus after June, May, and July 1978. The initial soil pH of 5.3, earlier it said 5.7, I thought, but now it says the initial soil pH of 5.3 and potassium and calcium levels of 0.1, and this unit doesn't make any difference. It won't make any sense to the audience, but the calcium and the potassium levels in the soil were sufficient, okay, for establishment. They didn't need to apply any calcium or any potassium. Response of the turfgrass species was similar. However, the magnitude and duration of ground cover and quality responses for the chewing fescue was less than for the other two species. Thus, the soil fertility levels may be less for chewing red fescue than for Kentucky blue or perennial rye. Now, I want to go back up to, that's it. I want to go back up to the abstract, because they actually summarize this much more succinctly in the abstract. Okay. So I'm just going to read the last couple of sentences of the abstract because it's more terse. Limestone applications did not affect ground cover, tended to reduce initial clipping yields, had little influence on turfgrass quality, slightly reduced sod strength, and generally did not affect tissue calcium levels. Potassium applications either reduced or had no effect on initial ground cover and had little effect on turfgrass quality. Although tissue potassium was substantially increased by potassium applications, tissue potassium levels of all three species on all plots not fertilized with potassium were still much higher than levels generally considered critical or deficient. So that the abstract was much more to the point and clear. Basically, there was no point to apply potassium. There's no point in applying lime. There was a benefit to applying phosphorus, especially the right after establishment, you saw the effect, and especially at the low phosphorus rates. Okay, so when you have phosphorus in your soil that's initially low and you're establishing turfgrass, this is evidence to support that the application of phosphorus. If your client's expectations are to have a great deal of rapid growth early on and get it established as fast as possible. Okay. I thought that was a very good paper. It's not exactly the easiest paper for me to go over because of the stats, but it's been around for ages, since 1983, and it stands the test of time. It is a very good paper. And there's a lot of papers that have been built upon this paper. And that, again, one reason why I'm convinced that phosphorus during establishment can hasten establishment is because of this paper. In addition to that, one reason why I tell people you probably don't need to apply phosphorus, even if it increases it, is because if your expectations are not get it grown in tomorrow, then you probably don't need to. But if your expectations are get it grown in tomorrow, then here's some evidence to support it. So this, if you were a lawn care operator and you're looking to justify selling this or justify to your clientele why they might need to apply phosphorus during establishment, this paper would provide plenty of evidence to support that management practice. Okay. Now, what I want to do is I want to go into a label. I started looking at some YouTube videos, and because I was looking for some information on lime and applying lime during establishment, because you hear this all the time. And I had no idea how much nonsense existed on YouTube for growing in turfgrass with lime. I had no clue. Some of the videos are quite long. There's dozens and dozens of them, but a lot of them use the same product. So instead of going over all these videos, maybe I'll go over a video on the Mondays members only channel. I thought I would just go over a product label, because sometimes those are fun to go over. So I'm going to go over a product label. Okay. In fact, before I do that, let me go back. I told somebody I would go back and answer their questions. So before I forget, let me answer some questions. So Mason RC, yeah, I told Mason I would answer his question. When you mentioned soil tests and levels of nutrients, you talked Malic 3. What's the difference between Malic 2 and Malic 3? UGA uses Malic. Malic 2 is not used at all. Malic 2 was a failure from the beginning. I think what you mean is Malic 1 versus Malic 3. Malic 1 are two weak acids, hydrochloric acid and sulfuric acid. Very, very weak acids. They're that particular extractant is not well buffered at the higher pHs. So it's typically a very strongly correlated only on acidic soils. So when you get up into the neutral soils or the alkaline soils with a Malic 1, because it's not a buffered extract, it tends to be neutralized. And essentially you're doing an extractant with water at the higher pHs, pH 7 or 7.5 or greater. So it's not very good at all for alkaline soils, Malic 1. Okay. But Malic 3 is very effective. It doesn't have sulfuric acid in it. It has ammonium nitrate and EDTA and some other elements in it. There's no sulfuric acid in it. That's the reason we can actually use it to determine sulfur. Anyway, it can actually be used up into the high 8s, around actually high 7s or low 8s. Okay, and I'm working on a paper right now. I was running SAS earlier today trying to get it to pull out these data and print it correctly. But it can be used up into the 8.1 range. I wouldn't want to go much higher than that because then the numbers start getting real screwy. But the value of Malic 3 is that it can extract and be very well correlated with turfgrass response to nutrients at pHs up to about 8, where Malic 1 is really only to about 7. But also, for turfgrasses isn't that important, but also Malic 3 is much better correlated with the micronutrients than Malic 1. With turfgrasses, I don't really have a lot of confidence in those micronutrients anyway, but Malic 3, and especially all the soil test labs that have converted from Malic 1 to Malic 3, aren't doing it for turfgrasses. They're not doing it for lawns and sport turf. They're doing it for row crops and for big ag. And in those crops, there is much stronger evidence to include the use of micronutrients, particularly in things like corn, where zinc can be a problem, and there's all sorts of low micronutrients that can be low. So Malic 3 is better than Malic 1 when determining micronutrient deficiencies. And it tends to be it can move a little bit higher into the pH range than Malic 1. Okay? So that's your answer to Mason RC. Should you use a different lab, Mason? So where did you say you were? Georgia. I guess you're in Georgia. So if you're in Georgia, I don't know all the soils in Georgia. I don't know all the soils in my lawn. But I would think you'd be safe with the University of Georgia. Typically, the land grant institutions will use an extractant that is appropriate for the soils in their state. I'm not saying Georgia does that, but generally they do. Okay, Malic 3 is not the universal extractant for every situation. I just made a good case where it's not a useful extractant when you get up into the 8s. You'd want to use an alkaline extractant for that. But Malic 3 is a pretty good extractant for a wide range of soils. Now, if they're using Malic 3, I would just stay with it. But I would venture to say that Georgia is using the correct extract for their soils. But I don't know what they're using, so I can't go too much further down that road. I don't know. Let's see. What other questions before I go to the label? Oh, my wife popped in the chat. Yeah, she said she likes those graphs. Okay. All right, guys and gals, let's get into the label. So the label I wanted to go over today is a label of a product I've never used. It's called Magical Plus by Jonathan Green. Now, I have looked at a video, a really wonderful con job video by actually two different videos. One of them is of a gentleman who claims to work for the Jonathan Green Company. He's given a seminar, and it's just a wonderful word salad BS seminar that is just indoctrination to a degree. It's comical. And then the other one, which I am going to go over, for the members only, I am going to be going over these soil test videos as standalone videos. The whole episode is just going to be videos. I'm probably going to start that either Tuesday or Wednesday of this coming week because the video is so long. But the other video is there's a panel. I can't remember. I haven't seen it in a while, but there's a panel, and I think all of them work for Jonathan Green. And it's just a wonderful video on how to sell stuff you don't need. Really, you don't particularly. They don't really even understand their product. The way they explain it is using base cation saturation and all this loosening of the soil nonsense. And so I'm going to be going into that either Tuesday or Wednesday. But this is one of the products. It's Jonathan Green Magical Plus. And I want to go over the label and explain a few things on this label as we get into it. So it says Jonathan Green Magical Plus, natural soil food for lawns and acidic plus hard soils. Now, anytime you see this phrase right here, plus hard soils, anything you say like this on a label of any product, that needs to go into my my manual of BS disorder manual, because that is almost always a very good sign that you're dealing with a BS artist and BS marketing machine, because there is really no product that's going to cure hard soils except this case, where you're dealing with a sodic soil that has dispersed as a result of the sodium, and you need to leach that sodium out of that sodic soil and reflocculate that soil. In that case, gypsum is essentially your only option, and it's a very good option. But that's the only case that's going to happen for the most part. Very rarely would anything else come up. But when you see a product like this that says lawns and acidic soil plus hard soils, that's right there where my ears start popping up. I start getting interested. If those of you who have been watching the channel for a while, I love going over this stuff. I could read this stuff all day long. I don't know why, but I love marketing nonsense. And that's one great example of foreshadowing to come when you see this on the front page, hard soils. So we're going to learn what can be done with hard soils in a bag. Helps raise soil pH. That's easy. Calcium carbonate can do that. A lot of different calcium oxide can do that. Helps loosen hard soils. Now, what I want to know is, okay, how do you know? How can you explain how that happens? Because I can put a lot of soil chemists on here, and none of them will agree that anything in here is going to loosen your hard soils except under the conditions that I just said. Okay. So we got some really good stuff going on. Loosening hard soils, and of course, raising pH is a no-brainer. Okay, let's continue. Now we get to the back of the bag. Now, I didn't highlight anything, but I do remember I had a couple things in here I wanted to go over, and it was, let's see if I can zoom in on, I don't know if I can zoom in on this or not. Okay, let's see if I can get this on here. Now, I'm going to have to fidget with the screen here a little bit because it's not going to fit. Hang on, hold with me just a second, guys. I'm going to move this over. Okay. So if it says feeding your soil, that's another thing. In fact, that might already be on the BS manual, the diagnostic manual for BS disorder. It might be on there already. Someone can correct me. I have a video on that. If you can go back and look, the diagnostic manual, it kind of gives some steps and some check boxes that you can check to see if you're dealing with a BS artist. And one of them may be feed the soil. I don't remember, but they have it listed in bold, feed the soil. If you're struggling to grow a great lawn and past poor soil is often the problem. That's true. It can often be the problem. If your soil is too acidic, blah, blah, blah. Okay, so Magical Plus for acidic soils contains calcium, which raises soil pH. Now, let me say this very clearly. Okay? Let's say this as clearly as I can say it. Calcium does not raise soil pH. I don't know how this gets into our lexicon. Calcium does not raise soil pH. Carbonate, the counter ion, it can be calcium oxide. It can be a number of other ions on the calcium, on the lime molecule, but calcium only exchanges the hydrogen on the soil exchange site, or aluminum on the soil exchange site. But the counter ion is what neutralizes the acidity component in the soil. Calcium will not raise soil pH. And they say it right here. So they don't know they don't even know their own product. Calcium, which raises soil pH, it does not. It improves cell wall structure. This is the Well, it's a straw man. I mean, it improves cell wall structure. Yes, the calcium does. I don't care. I've said it before. I don't care what the element does when I'm buying a product. I care what the product does when I apply it. Okay. What is the product I bought and put out? What is that going to do? Because there's plenty of calcium in the soil. Thousands. In fact, I'm going to show a soil test report. I think it's either on Monday or Tuesday of next week, where I ran into for the first time in 20-something years, I ran into the lowest soil calcium level I've ever seen on a Mehlich 3 test. And it was in the 200s. And the gentleman said his turfgrass looks horrible. His sod farm looks horrible. And I'm like, I can't believe I'm saying this, but you need to apply some calcium, either in case he had low sulfate too. So you need to apply some gypsum or something, because his calcium was so low and his turf looked bad that it warrants it. But your calcium is almost always going to be fine. Okay. And so I don't care if it improves cell wall structure. The calcium in the soil is going to do that. What is the calcium I'm applying going to do? Because if the calcium I'm applying going to do isn't going to do anything, then why am I buying it and applying it? That's what I care about. Lawns thrive in soils with pH levels between 6.2 and 7. That's true. But they also thrive in pHs well below 6 and well above 7. Otherwise, light green grass and weeds may persist while fertilizer nutrients are not fully used by the grass. This is just fear mongering, saying you must keep it within this range or your lawn's not going to look good. That's not the case at all. Magical Plus helps to break up clay and compacted soil. Now, how does that happen? How does it happen? Someone explain to me how, and I'm going to show you the label, what's in here, and there's gypsum in here, okay? But how is it going to break up clay and break up compacted soil if it's not already sodic? I mean, I'm open to being convinced. But I'm telling you now, it's not chemically possible for a product to do that unless it's sodic and it happens to be dispersed because it's sodic. Then it can help. Okay, but there's no magic bullet in this bag that's going to break up your clay and compacted soil, which improves, and it says it improves root penetration, promotes growth, and blah, blah, blah. Okay, so that's a bunch of silliness. Okay, now what it says is, here we go. Directions for use. Establish lawns, apply Magical Plus, It shows you how to do it. And then new lawns or overseeding lawns. This is why I'm showing this tonight, is because I just went over an article that discussed applying lime prior to seeding. Okay. And in all cases, but except I think there was one case where there was a slight benefit to applying lime. But in every other case, it actually resulted in a decrease in either growth or quality or some other desirable metric. Hold on one second. And here we are on this label, which apparently is a very common product. I've never seen it or used it, but apparently it's a very common product where I saw a lot of videos of people using it. And on their bag, this says, new lawns for overseeding lawns or sodding. When seeding or sodding, Magical should be applied with Jonathan Green Lawn Food for seeding and sodding. These products can be applied in any order, And then it says, shows you how to do it. Apply the spreader setting on the chart below. So now we go down here to the chart below. And here's the spreader settings. Excuse me, my voice is starting to go. See if I can get this on the screen here. Here's the spreader settings. And you'll see exactly why they want to promote applying it during establishment. So if you want to apply it for established lawns, they have a spreader setting, 4.5, or depending on the spreader, Scott's and so forth, And it says here on the right, new lawns or pH below 5.9, apply twice over the area at the same setting to the left. So in other words, for newly established lawns or lawn below 5.9, you need to apply twice as much. You need to buy twice as much of our material and apply 2 times as much. That's why they're marketing it, because they're trying to sell you twice as much. And I'm not saying that you wouldn't see a case where there could be a benefit. There may be a benefit in some cases. What I'm saying is, how do you know? Because it's clear evidence in the literature that applying a lime product to an acidic soil prior to turfgrass establishment might result in the opposite effect. It might actually result in a detrimental effect, a reduction in establishment, a reduction in quality. Okay, so here's the product label, just so we're all on the same page. We're being fair, that we're showing what's in it. If I can zoom in here. Hang on, let me try to get all this stuff on the screen when I have such a tiny screen. Okay, here we go. So calcium, guaranteed analysis, calcium, sulfur, iron. And it says derived from calcium sulfate dihydrate. So there's the calcium sulfur, that's the gypsum. Calcium carbonate, that's the lime. Iron humate, we all know that's completely useless, okay? I've shown many papers on that, and it shows that there's very little soluble, and after application, there's essentially zero soluble in the soil. It's iron oxide that's been ground up, so we know iron humate's useless. And soy protein hydrolysate, that's a useful product. I don't know why they don't have more on the label for that particular product, but nevertheless, and it has humic acids and some plant extracts and wood biochar. So basically, it's lime with a little bit of gypsum in it, with a little bit of humic acid and so forth, some stuff like that. So there's nothing in this except for the gypsum that would do anything to a lawn unless it's sodic. In terms of loosening it up, it's not going to loosen up anything unless it's sodic. And even if it was sodic, this particular bag has such low amount of calcium sulfate in it. You're better off just buying straight gypsum and putting it out. Okay. If indeed your compaction is a result of a sodic soil. Okay. So now what I want to do is finish this up with a quote that I love. And that is a quote from the USGA green section. We've talked about lime on establishing a prior to established turf. So pre-plant incorporated lime. We showed many cases where the application of lime results in reduction in quality, reduction in turf establishment, reduction in sod strength, a whole lot of reductions, even at 5.7, 5.3 pH when you start. Okay. Again, I'm not saying you would never see a response. There may be cases where you might see a response. Okay. But in those settings with those three turf grasses, there really was no benefit to applying lime. Prior to establishment, there really was no benefit to applying potassium prior to establishment. There was a lot of benefit to applying phosphorus prior to establishment. And then we showed a label with all the marketing material all over it saying, oh, you got to apply this pre-plant establishment and, apply twice as much as you would during established turf. Apply all this calcium and gypsum and lime and all this other stuff. It's an endless cycle of BS. Pseudoscience and salesmanship. To give you an idea how long this has been going on, this is 2024. In 1921, the USGA green section said, and many viewers of my audience already have seen this before, the bulletin of the green section of the USGA Greens Association on March 23rd, 1921. You can pull this up and read it yourself. Page 43, The Use and Abuse of Lime by Piper and Oakley. For over 100 years, this has been going on. There is still room, let me zoom in, there is still room for difference in opinion regarding the desirability of using lime on golf courses, but the weight of the present evidence is that as good or better results are secured without lime as by its use, certainly so in the case of bents, fescues, and probably so in the case of most other turf grasses. The vast amount of agricultural literature dealing with the use of lime and some enticing rhetorical statements such as lime sweetens the soil have conspired to lead many people to believe that lime is corrective for all the ills of soil and of turf. It is this belief that leads many misguided victims to scatter lime on their half-bare lawns every spring, with the simple faith that this will in some way ensure a dense cover of green velvet sward. Year after year, they do the same thing with exactly the same results as if they had not used the lime at all. A coarse lawn of crabgrass in summer and a cover of ghastly gray-brown dead turf in winter. But their faith never seems to weaken, and indeed against such faith no reason can prevail. I mean, it almost makes me choke up every time I read that last sentence. Against such faith, no reason can prevail. There's a saying, I don't necessarily agree with it, but you can't reason your way out of something you didn't reason your way into. And the people selling lime for pre-plant establishment, selling a bunch of products in a bag to loosen your soil, they didn't use reason to be convinced that that's true, because there is very little to no evidence, except for in sodic soils. There is no evidence to indicate that it is true. So they became convinced that this is, I'm assuming they're convinced. If they're not convinced, then they're liars. If they are convinced, then they're BS artists. But they became convinced for some reason other than logic, other than reason. So they're not going to be easily convinced using logic and reason, right? It's not going to happen. But what we can do is get the word out to the audience that has not yet been exposed to this indoctrination to help prevent them from going down the spiral, of BS and pseudoscience. Okay. So this is nothing new. It's been going on for over 100 years, selling lime on turf, especially during establishment, because there's got to be some magic to it. You got to increase the pH of the soil to 6.3, 6.5. No, you don't. No, you don't. I'm telling you. I don't know. I mean, the literature is telling you. There are clear cases where the 6s are best. There's no doubt about it. But unless you know exactly what's going on, your best pH might be 5.7. It might be 5.6. And applying lime to move it up just because you heard somebody say that, or just because you heard nutrients are more soluble at that pH, are not good reasons. There are clear examples where some turf grasses grow better in acidic soils. Other turf grasses grow better in alkaline soils. There's no question about it. But it's not because the solubility of nutrients is better or greater or higher or lower, whatever the case is. There's numerous things going on in the soil. And that's the reason I've said for many years, if your turf grass is acceptable and doesn't have any pre-existing conditions and the pH is 5, leave it alone. You might screw things up by dumping a bunch of lime on it. If it's not fine, or you do have some sort of pre-existing condition, by all means, let's talk about it and let's try to diagnose what's going on and help you. But if your turf looks fine, or if it's acceptable to you and your pH is 8, why are you going to dump a bunch of ammonium sulfate and sulfur on there? Right? You may have a turf grass that just prefers a higher pH soil than another turf grass. Meanwhile, if you killed that turf and put in another turf, that other turf might do horrible at that pH. It's the interaction of the soil with the plant that I think somehow has escaped everybody's thought process. The plant has an incredible ability to solubilize nutrients at a wide variety of pHs and a wide variety of cation ratios, wide variety. Okay, so the turf grass growing in that soil is the indicator. And I've said this before. I think I even said it on Tuesday night. You all know your indicator spots on your golf courses. You know your indicator lawns in your neighborhoods and on your routes. You know those lawns. You know on the area of the football field that just always tends to show up first. You know those areas. Okay, it's those areas you want to keep an eye on. And if it's habitual and if it's been around, you have a pre-existing condition, then those are the areas you want to start working on and use those as a baseline of nutrients or water or whatever the case is. But if the other areas are doing fine, why are you going to go apply lime? Why are you going to go apply elemental sulfur? They didn't do anything. Okay, that's my take on it. Monday morning at 10 a.m. will be the next members only show. And then I will commit to either Tuesday or Wednesday. I will do a video only show for the members only. I don't know yet. I have to look at my calendar, but it'll either be Tuesday or Wednesday of next week. It'll be nothing but probably one long video and me commenting on the video. It'll be a different take, a little bit of a different approach. It'll be more like just a comments video as I watch it. I'm intentionally not going to watch it over the weekend. I have seen it before, but I'm just going to open it up and start playing it and see how it goes. It might be a total disaster or it may be a raging success. I have no idea. But it might be a very long episode because I think the video is 30 or 40 minutes. And then, I blabber on for a while already. So it may be an extra long episode. All right, guys. Thank you for all watching and commenting. Mason, last question. I should have said UJ uses Malic 1. I just wasn't sure if one is more accurate than the other when it comes to... Oh, okay. So Malic 1 versus Malic 3 accuracy, it's not so much a matter of accuracy. I'm confident that both of those extractors are going to provide an accurate number so long as the pH is less than 7 on Malic 1 and the pH is less than 8 on Malic 3. If you're in the acidic soils, I'm comfortable with either one of those extractants. If you get up into the 7s, then you really need to be focusing more on Malic 3. But if they're using Malic 1, I'm assuming that they have a majority of acidic soils, I guess. I don't really know what the logic is there. Or they're not interested in maybe refining the micronutrient levels. I don't know. But there's nothing wrong with Malic 1 on acidic soils. I've done thousands of samples of Malic 1, even as a graduate student. So I don't have a problem with any of the extractants if they're used on the right soil, and Malic 1 on the acidic soils is perfectly fine. Chuck, I beat you on this one. It's not, but the guitarist tonight learned from Jimi Hendrix, or didn't learn, he played with Jimi Hendrix. I don't know if he actually learned from Jimi Hendrix, but he did play with Jimi Hendrix before he passed away. Jimi Hendrix passed away. This particular guitarist is still alive. Okay, guys, I'll let you go. Have a good one. I really appreciate everybody showing up, and I'll see you, the members, on Monday morning. See ya. Bye.